கொஞ்சம் பேர் என்ன சொல்லுங்க லாக்டவுன்
Hello guys, good evening. Hello. Could you hear me?
Yes, sir.
Okay. We have few minutes. Let's others also join, then we'll start. Good evening, guys. I can see Hanish, right? Okay. Nikhil is there, Hanish is there, Raghuram, Siddhant. Hi, Raghuram. Good evening. Vaibhav Singh, NPS YPR. Okay. Okay. Just wait for 2-3 minutes. We'll start. Bharat Nair, how are you?
Yes, sir.
Okay, guys, can you see the screen now? Is it visible? Good evening. All of you were there in the last class, last chemistry class. All of you were there, or is there anyone like who is attending the class this time, the first day? Hanish wasn't there. Okay, Aditra, Pranav. Okay, so why you were not there in the last session? You was not informed or what? Okay, fine. What about Aditra? Okay, Hanish also the same reason. Aditra, not informed. Cool. So not an issue, guys. Like since the last class we just had some general, excuse me, some general discussion regarding the the exams you are going to focus for, or the pattern we have for the exam, what all exams we have, and then the syllabus of chemistry. Then little bit we'll discuss about just it was just an interaction. It was not a particular topic. It was just a general interaction to understand uh, where you are actually, what is your level, and also that accordingly we can start. Okay. So like obviously, like officially, this is the first class we have as far as the chemistry syllabus is concerned, right? So whatever I have done in the last class, like since some of you were not there, so that won't affect you much here in this session, right? So that's the thing. But anyways, I'll just share that video with you uh, on the group, right? So on both the group I'll share that video. So if you want, you can go through all those videos, right, who was joining here for the first time. Okay, so that is not a big deal for today's session. Anyways, so this is the bridge course. Like you all know, we are going to have some basics discussion of chemistry, that the concept that will be using throughout the entire session of chemistry 11th and 12th grade. So that's how the program has been designed. Okay, so today we are going to start with uh, organic chemistry. Okay, last class also we were discussing some stuffs of organic chemistry. So we are going to start with this only. Organic. Okay. So you see there are a few things. Obviously, we are going to see the nomenclature part here, how to name a given organic compounds. Okay, why do we need that? Okay, and all those things we are going to discuss. Okay, but before that, we have few things that we have to understand. Okay, it's just we discussed before in organic chemistry before going into any chapter. Like the first of all, what do we study in organic chemistry? Any idea you have? What are we going to study in organic chemistry? Okay, just a second. Okay. Okay. So organic chemistry, we are going to study here or in this subject about hydrocarbons. Okay. So we'll study about hydrocarbon and its derivatives.
1 minute. No, 1 minute.
Okay. Hydrocarbon and its derivative. What are hydrocarbons? Any example? Carbon compounds, carbon based, carbon compounds, carbon compounds. Okay, organic carbon compounds, hydrocarbons. Okay, hydrocarbons and its derivative: methane, butane, ethane, propane. Okay, fine. So hydrocarbon and its derivative we are going to study here or in this subject, right? So hydrocarbon means what? The compounds of, you see, as the name suggests, compounds of hydrogen and carbon. So hydrocarbons are what? These are the compounds of hydrogen and carbon. Hydrogen and carbon. Yes, yes, yes. All of you guys, please write down your notes properly. Okay, yes. Last class only I have given you this, suggestion that everything you should write it down on your notes. Even there are many things that I will tell you, right? I won't write it here. I will tell you. Okay, I will dictate you, or when I explain some concepts, you will feel that I won't write everything there on the screen. Okay, your job is to listen to me very carefully and then write it down all those concepts. Usually I dictate concepts to the students. After explaining the concepts, I used to dictate those concepts to the students so that you can write your notes properly. Okay, so it's very important. Notes are very important in chemistry. Okay, so all of you write it down. So these are the compounds of hydrogen and carbon, and hence we call it as hydrocarbon. Correct. So any example of hydrocarbon? Any example? Yes, we can have, you must have this info. We can have alkane, alkene, and alkyne. Okay. Examples of hydrocarbon. For example, if I write down the simplest molecule that is methane. What is the formula of methane? CH4, correct? The formula is CH4. If you look at the structure, right, methane. The structure of methane you must have seen in the book. They have written like this. Have you seen this structure? You know the structure, right? What is the valency of carbon? 4. Tetravalent. Okay. So carbon can have maximum 4 bonds, correct? Carbon can have maximum 4 bond. More than 4 bond is not possible. Right? Okay. So you must have seen this structure, but it is not the actual structure of CH4. Okay, listen to me again very carefully. I said this is not the actual structure of CH4. Okay, what is the actual structure of CH4? Electron dot structure. No, that's, yeah, it's not tetrahedron, it is tetrahedral, right? So this is just to, represent the bonding of carbon and hydrogen. They have given this structure in the book, right? 10th grade book, basically lower grade book, they have given the structure. But the actual structure of CH4, if I draw, that structure is something like this. I will show you the structure here. The actual structure of methane is something like this. What is this? Yes, very good. But yes, ignore this. This is not the structure. That's what I mean. So the structure of methane is this. You see, carbon, this is the dark wedge, H. And there is a dotted wedge like this. This is H. Hydrogen, and this is hydrogen. Right? So this is the dark wedge, thick one. Okay. This is a dotted one, and these two has simple carbon hydrogen bond, right? When you look at this corner looks like a the corner of a tetrahedron. You look at this corner. This looks like the four corners of a tetrahedron has been joined. Try to analyze the three-dimensional structure. Does it look like a tetrahedron? Right? Okay. Where these three hydrogen atom is there in a plane, above that we have carbon, and above that we have hydrogen. So this is the actual structure of CH4. Okay. Right? Now this bond, which is a thick bond, we'll discuss this later also. This thick bond, it is a three-dimensional representation. Write down here, it is 3D representation. Okay, in which this bond, the thick bond that you have, it is coming out of the plane, towards the observer. No, they won't ask you to draw this structure in the exam, okay? Because the exam will be, it's a three-dimensional, it's a multiple choice question. You have to opt the options, okay? So they won't ask you to draw this, but for understanding of structure, this is useful, okay? Even few concepts also we'll discuss later on, where we use this representation of molecule. So you try to understand this. This bond is coming out of the plane, and this bond, which is the dotted one, is going into the plane, away from the observer. Away, simply I'll write down, okay? Away from the observer. You know what is the bond angle? What is the bond angle? You know that? Bond angle is this angle, the angle between the two bonds, like this it is. So here in methane tetrahedral structure, the bond angle is 109 degree 28 minutes. The exact value is this. Okay. Now, when you look at this structure, what does the bond angle look like here? 90°, right? It looks like 90°, but actually it is not 90°. Means if you think about methane, you should look this structure. You should imagine this structure. It is not this. Okay. Now, what is this structure? When you look at this structure, means this bond, this hydrogen, suppose if I mark this as hydrogen number 1, this is 2, right? The hydrogen number 1, it is coming towards you. Means you see the screen, the laptop screen is there. That hydrogen number 1 is coming out of the screen towards the observer. Means towards me, towards you. It is coming towards me, towards you. The hydrogen number 2 is into the plane. Means it is behind the screen, away from the observer, right? And they maintains the bond angle, that is 109° 28 minutes. Means this bond angle is also 109.28. This is also 109.28. This is also 109.28 minutes. So this bond is going into the plane. This bond is coming out of the plane, and these two bonds are in the plane of the screen, you can say. Means suppose if you draw the exact structure in the blackboard or whiteboard, in that way what we can say, these two bonds are in the plane of the board. Whatever board you have, these two bonds are in the plane of the board, right? This hydrogen is coming out of the board towards the observer, and this hydrogen is going into the plane, into the board, away from the observer, maintaining all bond angle here 109° 28 minutes. If it is clear, you can type CLR. Okay. So basically, when somebody says this thing, methane, right? Then the structure that you should imagine is this, not this one. Okay. To understand organic chemistry, you have to deal with this three-dimensional representation. That is one thing. I was talking about hydrocarbon. The simplest molecule we have in hydrocarbon is CH4. Just a second. 7:30. So I'll call you back 7:30. Okay. Yeah. Okay. So three-dimensional representation is this. What is the derivative of hydrocarbon? What is the derivative of hydrocarbon? Any example can you give me? Any example, guys? Derivative of hydrocarbon, chloroform. It's not chloroform, it's chloroform. Okay, chloroform, like you said, ethyl alcohol. Yes, very good, Weber. Ethyl chloropentane, very good, very good. So chloroform is it's also a derivative of like hydrocarbon, but it is trihalo derivative basically. What is the formula of chloroform? Anyone? Formula of chloroform? No, it's not CS3Cl, but it's CHCl3. Chloroform is this CHCl3. This is chloroform. Okay. Derivative of hydrocarbon means if the hydrogen of hydrocarbon, if one of the hydrogen of hydrocarbon is replaced by any other atom or group, then the compound that we get here, this compound we call it as the derivative or hydrocarbon derivative. Hydrocarbon derivative. I am going from the basics only, okay? So for example, if I take this one, CH3 like CH4, right? So this is the bonding we have, CH3 4. Now if I replace this H here by any other atoms or group, we can take Cl, we can also take CH3, hydrogen replaced by OH. We can also replace hydrogen by NH2, and there are many other examples, okay? Generally it is a non-metal, but not always. We can have some other compounds also. We can have some metal compounds also. Yeah, sodium acetate. Okay. So these are the hydrocarbons of uh, derivative of hydrocarbon. Now this part you see here, these parts CH3, 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 these are the alkyl group or alkyl part we have here. Right? Alkyl you get, you can say that Anurag, that's fine. Okay. Alkyl is what? When you remove one hydrogen from alkane. When you remove one hydrogen from alkane, it becomes alkyl. All these CH3, CH3, CH3 are the alkyl group. Okay. An alkyl group is generally represented by, in organic chemistry, it is represented by capital R. Capital R means alkyl group. Means this compound we can write it as RCl, ROH, and RNH2. RCl is an alkyl halide. You can also write that Swaraj, that's not a big deal. See, the point is, if you write this CH3Cl, CH3Cl, or the way I have written CH3CCl, okay, both way you can write, but the bonding is between chlorine and carbon here. Hydrogen is bonded with carbon, not with chlorine, right? Bonding between chlorine and carbon we have here. So it's better to write this way, CCl-CH3. It's a better way of representation of molecule. But when you write this, it is also right, it is not wrong. Okay, so this RCl is alkyl chloride. This ROH is alcohol. Bond angle here it won't change. However, the effect will be there. Little bit of effect will be there. But the bond angle we can consider it as 109 degree 28 minute. Okay, but like the atoms, surrounding atoms, lone pairs, all these have some effects on bond angle. Right? No, bond angle won't change here. No, it won't change. Bond angle of CS3Cl will be same. That is 109 degree 28 minute. It won't change. So let it be bond angle and all. We'll discuss that later. This is not the time to discuss that. Okay, because you see, for some questions you can ask me. Okay, but if I am, if I go to answer all those questions with all those reasons and concepts, then we cannot finish this chapter. We cannot do this. I have to discuss different things then. I can understand you will have a lot of questions now in your mind that why not this, why this. Okay, But in chemistry, you have to have some patience for for a few topics, right? When you do after 2 3 months of the discussion, then you will get to know why it is happening. Like suppose you're talking about bond angle now. Bond angle, the factors affecting it, we'll discuss that in a chapter called chemical bonding, right? There we'll discuss that. So for a few things you have to wait. Okay, if I start talking about this bond angle here, then I cannot go with this particular topic. Okay, so let's focus on to this. Whatever required here, we'll do that. Okay, bond angle, factors affecting it, we'll discuss in chemical bonding. Correct? This thing I have explained you just to give an idea. This structure we can define for all the molecules actually, but I cannot show you structures here for all the molecules. Okay, so that's the point. Right, so what I was talking about this alkyl group is represented by R. RCl, ROH, RNH2 is the alkyl halide, alcohol, amines, and all these are the derivative of hydrocarbon. Okay, so in organic chemistry, we'll discuss about this. We'll discuss about hydrocarbon and their derivatives, reaction of derivatives, preparation of derivatives. No, see, NH2 is not amide. Amide is something else, or no. Amide is CONH2. NH2 is amine. Amide functional group is this. No, it's not a prism. It's not a prism. We cannot say that. Okay. It has tetrahedral structure. Okay, so this is one thing. So in this organic chemistry, we are going to discuss about these two things only. That is hydrocarbon and its derivative. Now you see the representation of molecules. Okay, the heading you write down next. We have three different representations. I'll write down this way. Just a second. Let me drag this way. Okay. There are three different representations we have. We have, first of all, we have dash formula, we have condensed formula, and we have a bond line notation, bond line formula. Okay. So we'll discuss this with examples only.
So I have a question.
Yeah, tell me.
So like in the last class, you told us a little bit about bond line structure, that it's you draw just a line and you don't represent the carbon hydrogen bond. So for methane, what will the bond line structure be? Just a dot?
Not possible. Not possible. For methane, bond line structure is not defined. Not possible.
Okay.
Dash formula, condensed formula, and the third one is bond line. See, suppose if we take an example of ethane, right, or propanaldehyde. So propane, we have 3 carbon, 1, 2, 3, and 6 hydrogen, sorry, 8 hydrogen total. So this, when you represent all the bonds associated with all the atoms, then the formula is known as dash formula. In condensed formula, we do not represent the carbon-hydrogen bond, but we represent only carbon-carbon bond like this. This is condensed formula. Bond line formula is this. This is bond line formula. Just this is bond line formula. So in bond line formula, what happens? We do not represent hydrogen at all. This corner here, all these are carbons. And we know one thing is sure here, that carbon is tetravalent. Okay, so one carbon must have 4 bonds in it, right? So this carbon has one bond with this carbon. So it means here we have 3 hydrogen present. Like here we have 3 hydrogen. The same thing we have here. But hydrogen we do not represent. So that dot means carbon atom, and that dot is bonded with one other carbon atom. It means the terminal carbon has 3 hydrogen attached with it. Okay, 1 to 3 hydrogen here. Here this carbon attached with 2 carbon atom. So it means we have 2 hydrogen here. Here also we have 3 hydrogen. Any doubt in this? No? Butane is what? 1, 2, 3, 4, and all these carbon has hydrogen. So this is dash formula where all the bonds are shown here. H, H, and the condensed formula is CH3, CH2, CH2, CH3, and the bond line is 1, 2, 3, and 4. This is the structure we have. Okay, it's not a double bond, mind it. This is butane. All these are carbon. Again, one thing you must take care of. This dot I am putting here to make you understand. In bond line structure, we don't put dot like this. Okay, fine. Another structure you see, suppose for this molecule, C single bond, C double bond O, C 3 bond we have here, carbon hydrogen bond. And its condensed formula is CH3, C double bond O, CH3, and the structure is this bond line. The bond line structure is very easy to draw. Got it? If you have butene, the structure is this. Its condensed formula is this: CH3, CH double bond CH, single bond CH3, and its bond line structure is this. We have a double bond here. This is the 3 representation of butene. No, see, whatever we are discussing now, they won't ask this in the exam, first of all. But it is important for you to understand all these. The most convenient method, we generally use condensed or bond line structure. Okay, because these two structures are easier to draw. Bond line is the easiest one to draw. Okay, so they are not going to ask you this, but yes, they are the basics of organic chemistry. That's why we are discussing this. Got it? Okay. Now the other thing is, calculation of write down Sigma and pi bond. Okay. This one. Done? Okay. Now, calculation of sigma and pi bond. Do you have any idea what is sigma and what is pi? What is sigma bond? What is pi bond? You do not have any idea. How many of you were there with us in 10th grade? With us with Centum Academy in 10th grade? Who taught you chemistry there? Okay. Okay, Shraddha ma'am and Pratik sir. Fine. So you see, okay, one of the answer I am getting, sigma bond is single bond sharing of s shell electrons. Double and triple bonds happen between p shell of electrons. Okay. True to some extent. Okay, it's true. Actually, you see, I'll take one example to make you understand this. Whenever you have, like suppose alkane, let me write down this first. Alkane. Alkane has only sigma bond and no pi bond. This is sigma actually, this symbol. Pi is this, no pi bond. Actually, S shell and subshell are same thing. P shell and subshell are different. But for S shell and subshell are same thing. Right? If you have alkene, alkane only sigma, no pi. When you have alkene and alkyne, in this we have both sigma and pi bond present. Both sigma and pi bond present. Okay. Another thing, suppose you have, yeah, right, Arav. Suppose you have a double bond, right, and you have a triple bond. So in double bond, there is one sigma bond and one pi bond. In triple bond, there is one sigma and two pi. For now, just you have to keep this in mind. In a triple bond, we have one sigma and two pi. And in a double bond, we have one sigma and one pi. Okay, this you should keep in mind now. Okay, but again, yes, like I said, we have logics for this also. Okay, why one sigma and one pi, how this pi bond forms, right? There are many different things that we can discuss about it. Okay, why you are confused, Madhav? What happened? Tell me. See, sigma bond, just you see, if you have only one single bond, right? If you have only one single bond, it means that bond is sigma bond. But if you have a double bond, it means in that double bond, one bond is sigma and other one is pi. If you have a triple bond, In triple bond, one bond is sigma and other two bonds are pi bonds. Okay. What is the difference between sigma and pi bond? Sigma bond forms by axial overlapping. Pi bonds forms by lateral overlapping. Did you understand this? Quickly reply. I got only 2-3 response, guys. Please tell me. Lateral overlapping and axial overlapping. Did you understand that? Right. So you see one thing. Now listen to me carefully here. When I told you this lateral overlapping and axial overlapping, Charan asked me what? Sir, now, what's overlapping of bond? That's a genuine question. It's not, no, I'm not telling you why did you ask this. Before this, what did you ask me? What is, sir, what is the difference between sigma and pi bond? Right? I answered you this. Sigma is because of axial overlapping, pi is because of lateral overlapping. Then now you ask me what is overlapping of bond? I can bet you on this. If I explain you this overlapping of bonds, you can ask me 1,000 things on that. Are you getting my point? So what I'm telling you, there are few things that you won't understand now. So I am just giving you a few things that you should take as it is. Like I said, no, I cannot, Arnav. Axial, you do not know. It is AXIAL. Yes, do not. Okay, fine. So what I am telling you few things and you take this as it is. It is enough for now. This I can talk 4 hours on this, more than 4 hours on this overlapping of bonding, but that won't help you now. Okay. So what I'm telling you, I'm just telling you to calculate sigma and pi bond. For that, what you should know? You should know these 2 points, that in a double bond, we'll have 1 sigma, 1 pi. In a triple bond, we'll have 1 sigma and 2 pi. And that is it. This is enough for you to do this calculation. It's horizontal and lateral. Lateral means perpendicular. You can say it is correct to some extent, Arjun. Okay. But again, let me not, like, you don't drag me over there. It won't help you. Okay. I also put a lot of effort to make you understand this, and then although you won't understand. Okay. So don't let me, try to drag me over there. I'm telling you, we'll discuss all these things in chemical bonding. There is bonding, right? The name of chapter is what? Chemical bonding. Means how bonding takes place. What are the theories behind the bonding? Okay. Everything we'll discuss over there. Here, let me restrict myself over here, that in a double bond, what is this? Which bond is which lapping? Correct. Yes. Sigma is axial, pi is lateral. Anyways, let it be. Now what you have to do, you just have to consider this. A double bond has 1 sigma, 1 pi. A triple bond has 1 sigma, 2 pi. If there is only a single bond, it means it is sigma bond. First bond that forms between the 2 atoms is always sigma bond. Right? That's what I wrote here. Alkane, only sigma bond, no pi bond. Alkene will have pi plus sigma both. Right? So what you have to keep in mind, double bond will have 1 sigma and 1 pi. Triple bond will have 1 sigma and 2 pi. Okay. Now the calculation of this thing, sigma and pi bond, could you tell me here? And now this is just what you need to know over here. There's then one order in which sigma and pi bond forms. Okay. There are I didn't get you here. Sir, is there only one order in which sigma and pi bond forms? Overlapping of orbitals only gives you pi and sigma bond. Right. Can it be a sigma and pi? No, it is not sigma and pi. Both is not possible for one single bond. Yeah, in a double bond we can have. In a double bond, 1 sigma and 1 pi. No, pi bond is not possible. Pi bond won't form first. Why? For that also there's a reason. Okay, but that reason I don't want to go into that. Okay, then I have to discuss about internuclear excess. You know what is internuclear excess? Maybe you can understand by the term, but then I have to explain many things before that. Why the first bond is can never be a pi bond? For that also I have to discuss many things. So that's what I'm telling you. Don't drag me over there. Okay, I'm just giving you some facts, some things that you should know at this point, at this level. Just take that. Okay, reason behind all these things you will understand once we finish first 3-4 chapters of chemistry. You will understand that. Okay, so what you have to keep in mind, the way I said that double bond 1 sigma 1 pi, triple bond 1 sigma 1 pi. One note you write down here: the first bond that forms between the two atoms in a molecule, write down the first bond forms between the two atoms in a molecule is always a sigma bond. Finish. The first bond that forms between the two atoms in a molecule is always a sigma bond. Next point. A double bond contains 1 sigma and 1 pi. A double bond contains 1 sigma and 1 pi. Okay, I'm repeating. The first bond forms between the two atoms in a molecule is always sigma. Next one, a double bond contains 1 sigma and 1 pi bond, and a triple bond contains 1 sigma and 2 pi bonds. Okay. So could you tell me the number of sigma bond and pi bond in this molecule? Here on the top, I'll write down, this is sigma and this is pi. So we have 7 sigma, and 0 pi. Correct? When you draw the structure of this, it will be carbon-carbon single bond and single bond like this. This is the dash formula. We can see we have only single bond. So we'll just count all these bonds. 3 plus 3 plus 1, 7 sigma and 1, 0 pi. And again, it is an alkane, so there is no pi bond into this. The number of sigma and pi in this molecule. Ten or 11? Okay, so number of sigma bond here in the second one is 3 plus 3, 6, 7, 8, 9, 10, 11. We have 11 sigma and 1 pi. Okay, in this one, 1, 2, 3, 4, 5 plus 2, 7 sigma and 3 pi. Okay, they can also ask you the values of these kind of expressions, like calculate the value of sigma by pi, number of sigma bond divided by number of pi bond, number of sigma bond plus number of pi bond. They can ask you anything on this. So basically you need to count sigma and pi bond. Could you tell me the number of sigma and pi bond in this molecule? Okay, so I got all different answers. 10, 12, 4. Okay, so number of pi bond is very clear. It is 1, correct? Because we have only one double bond. Now 1, 2, 3, 4 sigma we have here. And this carbon has one hydrogen, 5. This has one hydrogen, 6. This has two hydrogen, 8. This has two hydrogen, 10. So we have 10 sigma and 1 pi bond. Hydrogen also you have to count. Tell me. Guys, mute. Arjun, what happened? What is benzene? Okay. Right. So in this molecule, we have 6 sigma plus each carbon has one hydrogen atom. So we have 12 sigma and 3 pi. Got it? Now, if I take this example, just a second. Fourth one. Copy this fourth one. Done? Okay. Now, what is your doubt? Okay. Have you seen this structure, that 0 in the middle? Okay. This structure is nothing but, it is also benzene. And this is the actual structure of benzene. Yes, Arav. Actual structure of benzene. Because this benzene in this pi electron is continuously shifting from this point to this point, this point to this point, here to here, here to here. So that circle represents the shifting of electron. It's not zero. It is just that the pi electron is continuously moving over the ring, right? It is continuously moving over the ring, right? It's not zero. Got it? So that means the continuous represents the continuous shifting of electron. So this also has 12 sigma and 3 pi bonds. Here, how many sigma and pi?
7.
We have 7 sigma and 5 pi. Here we have yes, it should be CH2. Should be CH2. Then it should be 8, right? 2, 3, 4, 5, 6, 7 plus 8. 8 sigma we have here. Okay. Now here, how many sigma? We have 2 pi in this, because the structure here, if I draw, CHO is like this. C double bond O and H. Right? So number of sigma, if you count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 sigma here. Similarly, COOH also, if you see, C double bond O, OH. So 1, 2, 3, 4. 4 plus 3, 7. 8, 10, 12. This also has 12 sigma and 1 pi bond. I'm coming to question number 2. See, CN is cyanide group, right? This is cyanide group, and the carbon nitrogen bond has a triple bond here. So 2, 4 plus 1, 5. Got it? So like this we can find out a sigma and pi bond, number of sigma and pi bond in a molecule. Understood? Okay. Now, the next thing you write down, degree of amines. Degree of amines. Amines are the, which one, the last slide you are asking, Arnav?
No, sir. This last question, the COOH. So how is it 12?
Or sigma bond? See, one OH will have here 1, 2, 3, 4 plus 3 sigma bond here, 7, 8, 2 hydrogen here, 10, 2 hydrogen here. Okay. See, 1 sigma here, 1 sigma here, 2, 1, 2, 3, 4, 5, 6, 7, 1 hydrogen here, 8 plus 2, 10 plus 2, 12. Okay. Degree of amines. What are amines? Amines are the alkyl derivative of ammonia. Ammonia, the structure of ammonia is NH3. No, not NO3, it's NH3, ammonia. Ammonia is NH3. And the structure of NH3 also, if you see, it is like this. Nitrogen with 3 hydrogen present like this. And 1 lone pair will be there in the orbital like this. And here also, the corners are at the corners of a tetrahedron like this. You see. This also has tetrahedral geometry, similar to methane. Yes, yes, but the bond angle is not same as we have in methane. Bond angle here is slightly less than that. It is somewhere around, bond angle, if you write down, it is somewhere around 107 degree, 107 point something it is. Which one, Vaibhav? See, n above n, it is an orbital in which the electron is present. Actually, nitrogen has 1 lone pair present on it. Lone pair of electron is unshared pair of electron. Like you must have seen, similarly, you must have seen water molecule structure. So oxygen has 2 lone pair on it, 2 bond pair and 2 lone pair. right? HF. No, it's not coordinate bond. It's just a, see, these two electron pair, where it is present in the orbital, right? So this thing is the orbital of nitrogen, where the electrons are present. You know, orbitals are something, it is like the bedroom of atom in which the electron resides. Like for us, we have a bedroom in our house, right? And we used to no, stay or sleep or live there in the bedroom. Similarly, for atoms, the bedrooms are orbitals, right? And in the orbitals only electrons are present. So this dumbbell thing, this is the thing that you are looking at here. This is the orbital of nitrogen atom in which the lone pair of electron, this electron pair, is present. Peace. Right, 3 pair of electrons are there, and one pair of electron is unshared, right? So that one, the unshared pair of electron is the lone pair. The shared pair of electron, we call it as bond pair of electrons. Like you must have this information that in this bond there are 2 electrons present, right? So these electrons are shared pair of electron. What determines the bond angle? Again, we'll discuss this in chemical bonding. Yes, we'll do that in chemical bonding, definitely. Yes, it is a Lewis base because ammonia has a lone pair and it has tendency to donate the lone pair of electron, hence Lewis base. Yes, it will become unstable, but it has tendency to donate. Tendency, if it is there or not, yes, it is. It becomes unstable. That's the another debate. We'll have other factors also which stabilize the ions over there. Okay. So all those things again we'll discuss later. Provides electron. Correct. Okay. So degree of amines. Amines are the alkyl derivative of ammonia. So ammonia is NH3. Lewis base are those compounds which has lone pair of electron and they have tendency to donate lone pair of electron. Those are Lewis base. So ammonia is a kind of Lewis base. It behaves as a Lewis base. Even water also to some extent behaves as a Lewis base. Okay. So alkyl derivative of ammonia, ammonia is NH3. Now in this hydrogen, if you replace this hydrogen by alkyl group, it becomes what? It becomes RNH2. Again, another hydrogen replace by alkyl group. It is RNHR. Further, if you replace the third hydrogen, this is the derivative of ammonia. So when only one, R is nothing but the alkyl group, like where methyl, ethyl, propyl, etc. When we have only one alkyl group present, then it is known as 1-degree amine. When we have 2 alkyl group, then 2-degree amine. 3 alkyl group, then it is 3-degree amine. Got it? Copied? Okay, copy it down. Okay, next. Like we have degree of amines, similarly, we have degree of compounds. Okay, degree of compounds, degree of carbons also we can say. So what is a degree of compounds? Write down the heading. Okay, in this, 4 different types we have to discuss. First is 1 degree carbon, or we also call it as primary carbon. Write down. When the carbon attached with only one carbon, when the carbon attached with only one carbon, it is known as 1 degree carbon or primary carbon. Okay. When the carbon attached with only one carbon, it is 1 degree carbon. We'll discuss. Wait. 2 degree carbon, we also call it as secondary carbon. So secondary carbon is the carbon attached with two carbon atom in a molecule. 3 degree carbon, we also call it as tertiary carbon, and this is the carbon attached with three carbon. And the last one is 4 degree carbon, or we also call it as quaternary carbon. Okay, so the carbon that attached with 4 carbon. Finish. Yeah. For methane, it is not defined, Madhav. This definition, degree of compound or carbon atom, is based upon the bonding of carbon. So when the carbon attached with the number of different carbon atoms, on the basis of that only it is defined. What is the structure of diamond? What is the structure? It is tetrahedral, right? So it means each carbon atom is quaternary or 4 degree. Tell me, what is the degree of this carbon? This is 1 degree. And what about this one? 1 degree. What about this one? 1 degree, 2 degree, 1 degree. This carbon atom is 2 degree. This is 3 degree, 3 degree, 3 degree, 1 degree, 2 degree, 1 degree, 2 degree, and 1 degree. Is it clear? Assign the degree on each carbon atom here. Done, all of you? Just a second. Let me know once you're done this. Understood. Yes. So here if you assign the degree, all these carbon atom 2 degree, 2 degree, 2 degree, 3 degree, 3 degree, 2 degree, 2 degree, 2 degree, 2 degree and 2 degree. Correct? This carbon atom 1 degree, 3 degree, 2 degree, 2 degree, 3 degree, 2 degree, 3, 2, 3, 2, 4, 1, 1, 1, 3, 3, 2, and 2. No doubt? Okay. So these are the degree of carbon that you should know. Now we'll see the hydrocarbons, types of hydrocarbons, its classification basically. So hydrocarbons basically classified into two types. One is open chain and closed chain. There are many other classification, but we'll concentrate only on these two. Open chain we have two types, saturated and unsaturated. Saturated hydrocarbons are nothing but alkanes. Unsaturated are alkenes and alkynes. Are alkenes and alkynes. Alkanes, we also call it as paraffins. Alkenes, it is olefins. What is the general formula of alkane? CnH2n plus 2. So the formula here for alkane is CnH2n plus 2, H2n for alkenes, minus 2 for alkynes. Okay. This closed chain again classified into two categories, homocyclic and heterocyclic, and further classification we have. Paraffin is the other name of alkanes basically, that is it. Fin, it is not M in the last, it is paraffins. Paraffins. Alkyne is nothing, it's just alkyne. Okay. Closed chain further classified into two categories, homocyclic, heterocyclic. Homocyclic again we have aromatic, alicyclic. Aromatic again benzenoid, non-benzenoid. But that part you let it be, it is not required now. Okay, so we'll discuss that later. Okay, the other classification, it is given in the book also, you can go through. So first of all, you see alkanes are what? Alkanes are only open chain hydrocarbons. Closed chain hydrocarbons are not alkanes. Like for example, if I draw a structure here, this one, is this an alkane? Is this an alkane? Is this an alkane? No, because these two compounds are what? These are not open chain hydrocarbons. This is open chain hydrocarbons known as alkane, and the name of this compound is butane. These are what? These are cycloalkane. The general name, if I write down, it is cycloalkane. Could you tell me the name of this compound, the four-membered ring? Cyclobutane. Okay, so this is how the classification is. You must understand this, that closed chain hydrocarbons are not alkanes. Okay, alkanes are only open chain hydrocarbons. Correct. So the next thing is, suppose I'll give you one molecule, say C3H6O. Could you draw the possible structure of this? Have we discussed DOU? Okay, so we have discussed DOU. So those who are new today, I'll just go through it quickly. Okay, guys. So understand this. To write down the structure of this compound, we should find out the double bond equivalent here. Right. That is degree of unsaturation. Or we also call it as double bond equivalent. That is DBE. Both are same thing. Okay, both are same thing. The formula of this DBE or DOU is equals to C plus 1 minus H plus X minus N divided by 2. C is the number of carbon atom, H is the number of hydrogen atom, X is the number of halogen, and N is the number of nitrogen atom. Oxygen we do not consider here. So if you find out DOU for this, this will be 3 plus 1. C is the number of carbon atom, H is the number of hydrogen atom, X is the number of halogen atom, N is the number of nitrogen atoms. So it is 3 plus 1 minus H is 6. There's no halogen, there's no nitrogen, divided by 2. So it is coming out to be 1. Now if no, propanol is not possible. Propanol is, we can say propanol is possible. That structure also we can draw. Okay. Propanone is also correct. Yeah. So DOU, one means what? When you draw the structure here, you are going to have at least one double bond in the structure. You can draw one ring or one double bond into this structure. So one possible structure is this. If you try to write it down, you'll get CS3 C double bond O, CS3, and the another structure you can draw CS3 CH2 CHO. Okay, it is an aldehyde and it is a ketone. Okay, we can draw another structure as CH2 double bond CH single bond CH2OH. This is the structure also you can draw. Okay. Even if you consider one cyclic structure here, then one more structure possible. You see this OH. This is also the same molecular formula. So actually this value DOU gives you an idea that how many double bond or ring structure is possible in a given compound. Okay, so I have discussed this thing in detail last class. Okay, little bit also I have discussed it now. Anyways, I'll share the video of last class. You can go through it once again. Okay, just you have to keep that formula in mind. That is it. Okay, so now the basics we have already discussed, understood. Now we'll see the nomenclature of compounds. Okay, how to cyclopropanol, correct? Yeah, the last one is cyclopropanol. IUPAC nomenclature. Okay. Okay, so there are the structure of this thing. Nomenclature is the structure is prefix, and then we'll write a root word, and then we'll have primary suffix, and then secondary suffix. This is the structure. Yes, but it was not specifically nomenclature. We have discussed other things also. Now we are going into this. Okay. Prefix, root word, primary suffix, and secondary suffix. Suppose if I write you this example, if I give you 1-chloro butanol, or if I write this way, not 1-chloro, could you write down the structure of this compound? What is prefix in this compound? Prefix is chloro. What is root word? What is root word? Root word is but. What is the primary suffix? What is the primary suffix? N. And what is the secondary suffix? That is O, right? So root word is what? It actually represents the number of carbon atom in the parent chain. Okay, so root word is the number of carbon atom in the parent chain. What is the parent chain?
The longest carbon chain?
Yes. So root word is the number of carbon atom in the parent chain. Okay, parent chain is the longest possible carbon chain. Longest possible carbon chain. Okay, so that is what we have to identify. Okay, the structure I have given you, that is prefix plus root word plus primary suffix plus secondary suffix. If anything is not present into the molecule, we'll drop that particular thing, right? So now nomenclature is nothing but rules. It's all about rules. Okay, rules is already defined or given, so we have to just follow those rules to write down the name of any compounds. Okay, so what are the rules we have? So write down the heading first of all, nomenclature of alkane. Heading, all of you write down nomenclature of alkane. Nomenclature of alkane. Like I said, we have to follow the rules for that. The first rule you write down, select the longest carbon chain. Rule number 1, we'll select the longest carbon chain. We'll select the longest carbon chain. Rule number 2, you write down. When the two carbon chain has equal number of carbon atom, when the two carbon chain has equal number of carbon atom, then the one which has more number of locants or substituents than the one which has more number of locants or substituents is considered as the principal chain. More number of, I'll show you all these things with some example. First, rules you write down. Okay, the one which has more number of locants or substituents is called locants. Is the side chain. I will explain all this. Okay, just write down the rules. We'll explain all these. Is called the principal carbon chain. Rule number 3. The substituents or locants must get the lowest possible number. Must get the lowest possible number. Next point. Next point, if there are more than one substituents present, if there are more than one substituents present, then the numbering will be done in such a way that we get the least possible number of locant. Write down like this, in such a way that we get the least sum of locant. Don't write locants, write locant without s. Least sum of locant. Next, right, the substituents must be written in alphabetical sequence. Okay, The substituents must be written in alphabetical sequence. Write down next. If the sum of locant is coming out to be equal, sum of locant is coming out to be equal, then we'll give the least possible number, then we'll give or assign the least possible number to the locants which comes first in alphabetical sequence. Which comes first in alphabetical sequence. Okay, so these are the rules we have for the nomenclature of compounds. Basic rules are this. Now the actual understanding you will have once you solve the question on this. Okay, so you see, one by one we'll discuss these rules first of all, and we'll try to understand. So first of all, you see, if the compounds are like this, 1, 2, 3, 4. This is the compounds given, right? First of all, what we do, the first rule is we'll select the longest carbon chain. We'll discuss that. Wait, I'm taking examples, I'll let you know. Okay, in this one, we need to first understand the rule number 1, which is to select the longest carbon chain. So longest carbon chain in this one, if you see, it is this. This is the longest carbon chain. Okay, longest carbon chain is this, and this group which is not involved in this parent chain, this group we call it as locants or substituents, or we also call it as side chain. Side chain, that is also right. Okay, this one from here to here, this one we call it as principal chain. Okay, principal chain. Now once you assign that the locant, you find out the locants and the principal chain, you have to assign the number, because we have to specify the position of this locant. See, locants is the substituents, but locant, if you write, it is the position of that substituent. Position of substituents. So when you do the numbering of this, position of substituents must be specified. You have to specify at what position the substituents is present. Okay. Now to specify a position, we'll do the numbering here, right? And numbering we cannot start in between, right? From in between, right? We cannot start in between the numbering. We have to start from the either side, from the terminal carbon, either from this carbon or from this carbon. No, we cannot. Do that. Now, should I continue? If you take this as the longest chain, then this becomes substituents, which is the same thing. Okay. So now this is the longest chain. You can take this one or this one. It does not make any difference here. Okay. So now when we have the longest chain position, we have to define. So we have to do the numbering over here. So we can start from this carbon 1, 2, 3, 4, 5, 6, 7, 8. Or we can start other way from this carbon. So if you start other way here, you see the numbering will be like this. You go 1, 2, 3, 4, 5, 6, 7, 8. So both way you see the position of locant here is different. Left to right if you go, it is at the fourth position, the red one, and right to left if you go, it is at the fifth position, the yellow one. Okay, so we'll choose the numbering in which the position of locants is minimum, right? So the preferred one is left to right. So yellow one we won't consider here, right? So we'll just remove all these yellow numbering that I have done here. The correct numbering is the red one, and at fourth position we have the substituents present. Hence the name of this compound is 4. This group is propyl, right? So 4-propyl octane. Okay, this is the one thing. Now if you consider this molecule, the another example, if I take 1, 2, 3, 4. Tell me the longest chain here. See, in the substituents you see we have 3 carbon atom. So meth, eth, prop. The root word is prop. So prop, if it is attached to the parent chain, then it is propyl. Alkane, one hydrogen you remove becomes alkyl. So 3 carbon atom, propyl it is. Okay. So in this too, if you see, if you consider this chain, the straight chain and this one. Okay, these are the 2 possible carbon chain we have, which has equal number of carbon atom, correct? That is 7 and 7. So which one will choose? The straight one or this one? The blue one or the white one? Which is the correct one? The longest chain. Why the blue one? Because if you see, both has, it is the rule number 2. If the number of carbon atoms same in more than one carbon chain in a given compound, then we'll select the one which has more number of branch, okay, more number of substituents. So if you see the white one, if you take, then there is only one substituent, which is this. But when you take the blue one, it is 1, 2 and 3 substituents we have here, right? So here the substituents are, this is one, the substituents are, this is the one substituents, this is the another substituents, and this is the third substituents here. All these green ones are locants or substituents. Substituents, right? And when you do the numbering over here, should we start numbering from this side or this side? See, if you start from this side, it is 1, then 2, then 3, 4, 5, 6, and 7. Okay. If you start other way, then you will get 1, 2, 3, 4, 5, 6, and 7. Okay. So since we have more than one substituents, so we'll see the sum of locants rule. So if you see this one, the purple one that I have done, in the sum of locants is what? Is equals to 4 plus 5 plus 6, that is 15. Or I'll write down this. It will be 4 plus 5 plus 6, 15. And sum of locant for the other one is 2 plus 3 plus 4, that is 9. So we'll follow the lowest sum of locant rule. So this is the lesser value, it is right, and this one is wrong. So we won't do the numbering this way. Okay, all these numbering we won't consider. Right? So this is the correct numbering we have, and the name of this compound at second position we have methyl, At third position, we have methyl. And fourth position, we have propyl, right? So methyl and propyl, the one which comes first alphabetically, that will write first. The name of this compound is the methyl 2-methyl present at second and third position. So it is 2,3 dimethyl 4-propyl heptane. Did you understand this? Any doubt? Okay. One more thing you must take care of. The numbers are separated by comma, 2, 3. Numbers and letters are separated by hyphen. Clear? Yes. So hyphen and comma are very important. If you write down these things, like if you do not write comma here, or if you replace these two with each other, then you'll get 0 marks in the exam. Okay. So must keep that in mind. Okay. Some more examples you see. Do all this. Are you done? All of you? Okay.
Sir, I have a doubt.
Yes.
Do we do in the order of the numbers, or should we do alphabetical order?
We'll follow alphabetical sequence.
Okay.
Okay. See, first of all, in the first one, obviously the straight chain is the longest chain. Okay. So this is the longest chain we have. And we'll do the numbering from left side or right side. See, if you do it from left to right, you get 1, 2, 3, 4, 5, and 6. Right to left, if you do, you'll get it as 1, 2, 3, 4, 5, and 6. So you see, left to right, you are getting at third position methyl, and right to left, fourth position. So you'll see the lowest set of locant, that is 3, right? So the correct numbering is from left to right, and hence the name of this compound is 3-methyl, 3-methyl hexane. Without any space, we'll write down this 3-methyl hexane. Now in this one, the longest chain is this, and we'll start the numbering from the left side, left to right. 1, 2, 3, 4, 5, 6. So 3-ethyl, 2-methyl. Okay. So 3-ethyl first alphabetically, then 2-methyl hexane. We'll write alphabetically first. Here, the numbering obviously will start from this side. 1, 2, 3, 4. Okay. So we'll write bromo first and then chloro. So this is 2-bromo, 1-chloro, butane. Okay. The next one, 1, 2, 3, 4. Or this side, if you see 1, 2, 3, 4. So the sum of locants is 2 plus 3, 5 only, right? When the sum of locants are same, then we'll prefer the locants which comes alphabetically first. Means we'll provide the least possible number to the locant which comes first alphabetically, right? So the correct numbering is from the left to right, okay? And hence the name of this compound is 2-bromo 3-chlorobutane. Two bromo 3-chloro butane. In this one, the numbering will start from the left. 1, 2, 3, 4, 5, 6. Okay. So what is the sum of locants here? Sum of locants will be 2 plus 2, because we have 2 methyl group, and 4. So that will be 8. Other side, if you do 1, 2, 3, 4, 5, 6. Sum of locants will be 5 plus 5 plus 3, that will be 13. So obviously we won't follow this, but we'll follow this one. Okay, hence the name of this compound is, we have methyl and ethyl. So what we'll write first? The name of this compound is, we'll write 4-ethyl 2,2 dimethyl. We'll write alphabetically 4-ethyl 2,2 dimethyl hexane. If 1-methyl was not there, then also it is the same, 4-methyl 2-ethyl hexane. Di does not matter here because the substituent is not complex. One note you write down here. One note you write down. The di-tri, write down di, comma tri, comma tetra, di, tri, tetra, etc. are not considered in alphabetical sequence if the substituent is not complex. I am explaining, wait. This one you write down, if the substituent is not complex. Okay, the di, tri, tetra, etc. are not considered in alphabetical sequence if the substituent is not complex. What is complex substituents? We'll discuss that. Okay, so here what happens, you don't consider this. For alphabetical comparison, we'll compare methyl, M of methyl and E of ethyl. We won't consider this D because the substituents is not complex. Okay, one more thing you should take care of here, that after hyphen, the first letter you should write in capital. The first letter you should write in capital, right? And after that, there should not be any letter in capital. Okay, so I forgot to mention here, the first letter must be in capital. After hyphen, here and here. Then it will be small everywhere. Then also it is only first letter will be capital here. The first term here, this is a small only, you see, this is small only. Okay, the last one again I'm explaining here. The numbering is this, we have 2 dimethyl, 4-ethyl. So dimethyl, the substituents is not complex. What is a complex substituents? I'll tell you. Suppose if you have a molecule, this one. Suppose if you have a molecule this, what I'm telling you, that here this di, tri, tetra, it is not involved in alphabetical sequence if the substituents is not complex. Okay, So what is a complex substituents? Complex substituents is a substituents which has branch. Okay, so this example you see, right? So this example you see here, the parent chain is nothing but this 1, 2, 3, 4, 5, 6, 7. This is the parent chain. Now in this 4, you can take carbon chain or this carbon chain, where you have to start numbering from this one. We also write it as 1 prime and 2 prime. So 2 prime you can take either this carbon or this carbon. So branch itself contains branch, right? The branch itself contains branch. This substituents is the complex substituents. So when you have complex substituents, we'll consider di, tri, tetra into alphabetical sequence. Otherwise, we won't consider. It's isopropyl. We generally write a number. Okay, we can write 1 prime prime, 1 double dash, we can write. Okay, I'll see that. It's ethyl and methyl. Yeah, 1 methyl. Yeah, it's correct. Fourth position, 1 methyl ethyl heptane. It's correct. Yeah, we'll see this later. Okay, we'll see the nomenclature of these complex substituents later. Yeah, right, correct. In the substituents also, we'll select the longest chain. The rule is same only. How can we include substituents into the longest chain? We will select the longest chain. Whatever carbon atom we could not take into that longest chain, that becomes the substituents or side chain. Okay, we'll try to get the longest possible carbon chain. And whatever is left behind, whatever we could not include into that longest chain, that becomes the substituents. Okay, understood this? Yeah, so the complex substituents nomenclature we'll see later on. Okay, so fine, we'll take a break now. We'll come back at 6:40. Okay, you don't have to leave this meeting. Okay, just you pause this, mute yourself and let it be. We can start the session, resume the session at 6:40. Okay, take a break. Hello? Hello? Yeah. Shall we start? Hello? Okay. Can you hear me, all of you? Okay, fine. So let's do some problem on this nomenclature of alkane. So the first question, the name of this compound. Do these questions. Okay. So what is the answer in the first one? It's 1, 1, 2, and 3. So at second position, we have 2 methyl group and bromo, right? So it is 2 bromo, capital B, This one is 1, 2, 3. 1, 2, 3, 4. So 2 is fluoro and this is methyl. So we'll start numbering from here. 1, 2, 3, 4, 5, and 6. So the name here is 3-chloro-4-methyl capital C hexane. Okay, this the numbering will start from this side.
Sir, one doubt, sir.
Yeah.
The first one, how is it possible? Because the second carbon atom will have 5
Oh,
bonds.
I have taken 5 bonds there. Okay, so just will change this. The diagram is wrong, guys. Just make a change over here. Now it's fine. So this 2-methyl we have, dimethyl is not possible. Correct? Thank you. So it is 2-methyl, 2-bromo, 2-methyl, propane, right? Yeah, correct. 5 bond is not possible. So it is 3-chloro-4-methyl hexane. What is the numbering here? We'll start from this carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this will be 5 we have ethyl, 6 methyl. So first we'll write ethyl. So 5 ethyl, 6 methyl, decane. 10 carbon atom is decane. This one will start numbering from here. 1, 2, 3, 4. So 1-chloro-3-methyl butane. The first position we should give to this carbon or this carbon? Right or left? The right one, sum of locates rule we have to follow. So 1, 2. So 1 bromo, 1 chloro, 2 iodo, ethane. Okay. All of you understood? Any doubt in this? Correct. Now you see some more examples here. CCl3, CH3. Name of this compound. Done, all of you? Okay. So name of this compound, it is 1 and 2. So 1 comma 1 comma 1 trichloro ethane. This will be what? We'll start numbering from left or right. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So 4 ethyl, 4 ethyl, 5 methyl octane. In this molecule, we'll start the numbering from the right. One, 2, 3, 4, 5, and 6. So it is 3 ethyl, 2 methyl hexane. Okay. Now we'll see some examples of cycloalkane. Nomenclature of cycloalkane. If you start from here, from the top, we'll get only one substituents. Okay. And if you start from here, we'll get 1 plus 2, 2 substituents. So we'll select the one which gives more number of substituents. Clear? Understood this? Right. So that's the reason. Siddhant, understood? Yeah. So nomenclature of cycloalkanes. Could you tell me the name of this compound?
Methyl cyclohexane, the ethyl cyclo. Ethyl cyclopentane. 1, 2, 3, 4, 1, 2, 3. Cyclopropyl.
Okay. So now the first one is, it's the easiest one. 6 carbon atom in the ring we have. So it is cyclohexane. Methyl is present on cyclohexane. So the name is methyl cyclohexane. Methyl cyclohexane. Or you can write 1 methyl cyclohexane, that is also fine. Similarly, this one is ethyl cyclopentane. Okay. Now in this one, here all these things you see, the parent chain is the ring. Okay. The ring is the parent chain here. Parent chain. Here also, the ring is the parent chain. But in this molecule, the number of carbon atom in the open ring, open chain, this one is more. Hence, this is the parent chain here. So in cycloalkanes, if the number of carbon atom is more in the acyclic chain, then that becomes the parent chain. So this is the rule we have. So write down this rule. Note this point first. We'll see the name. The ring is considered to be a principal carbon chain. Considered to be a principal carbon chain till the number of carbon atom in the ring considered to be a principal carbon chain till the number of carbon atom in the ring are greater than or equal to till the number of carbon atom in the ring are greater than or equal to the number of carbon atom in the substituents. So here you see the ring has 3 carbon atom, but this chain has 4 carbon atom. So this becomes the parent chain and ring becomes the substituents here. Position of substituents is the first. So we'll write 1 cyclopropyl butane. 1 cyclopropyl butane. Yes, equal also the ring is the parent chain.
Sir, but we don't need to write 1, right? Because it's obvious that.
Not required. Yeah. If
Yeah.
you don't write 1 also, it's fine.
Yeah, because it will be in the first carbon.
Yeah. Okay. What is the name of this compound? The previous one is cyclopropyl butane. 1 cyclopropyl butane. Acha, we'll take that one also. We're talking about this 1, 2, 3, 4, and here we have. Okay. In that case also, the parent chain is this only. Position of cyclopropyl is different. So it is 2 cyclopropyl butane.
Eh? Panji, but I missed some point.
Okay. In this case, you see, either you can think about this carbon chain, which is 1, 2, and 3 carbon we have, or you think about this cyclopropane. Okay, so obviously the number of carbon atom is same in both the open chain structure and the ring structure, right? So obviously we have to take the parent chain as the ring. So it is first, second, and third, right? And this, you see, with respect to this ring, either this one or this one is the branch. So this is 1 prime, and suppose I have taken this one 2 prime. So this becomes the substituents of this branch. So this is what? This is complex substituents. Overall, this is the complex substituents we have. The branch itself contains branch. So it is complex substituents. Okay. So this we can write it as, at first position, we have 1 prime methyl ethyl cyclopropane. Okay, because if this is not there, assume like this, if this is not there, this one is ethyl cyclopropane, right? If this is not there, this one is ethyl cyclopropane. But once this methyl group is attached here, this becomes the branch of this branch, right? If you attach the methyl group here, this becomes the branch of this parent of this cyclic ring. So this overall, it becomes a complex substituents. Okay. So this is the parent chain of this substituents, and the parent chain is ethyl, not methyl. And this methyl is the branch of this parent chain. So first of all, we write the position of this methyl at 1 prime, and the entire this substituent is present at first position. So it is 1 dash 1 prime methyl, then ethyl bracket close cyclopropane. Did you get it?
Sir, won't the straight chain take the priority because it has a functional group?
Where is the functional group?
The alkyl group.
Alkyl group is not the functional group. Alkyl group is not the functional group. Either you can take this chain as the parent chain or this ring as a parent chain. So what I told you, the number of carbon atom in the chain is 3, in the ring is 3. So the ring becomes the parent chain. Now when the ring is the parent chain, see, I'll explain this. This is the ring we have, right? And suppose this is the group attached. What is the name of this compound? Tell me.
That will be ethyl cyclopropane.
Cyclopropane. So ethyl is the substituents. So once
Yes.
you attach one more methyl here, right, then also either you can think this chain as a parent chain, or you can think this ring as the parent chain. What is the condition for that? Number of carbon atom. Number of carbon atom in the chain is 3, and in the ring again it is 3. So this ring is the parent chain. First of all, it is fine. No doubt in this.
Oh, okay, sir.
Correct. Now,
Yeah.
if this becomes the parent chain, so we have to see the substituents here. So what is the name of this compound here? Could you tell me the name of this compound? This part which is attached to this ring? What is the name of this part? See, in complex, first of all, you see this. This is the parent chain we have, and this group, this carbon is attached with this parent chain. So always we have to start numbering of the substituents from the carbon atom which is attached to the parent chain. Like for example, if I take the simplest example here, if I take this molecule, or suppose like this we have, if I take this molecule, so what is the name of this compound? Could you tell me? If I have chlorine here, could you tell me the name of this compound? One chloroethyl hexane. So why you have given first position to that chloro? If you write this as 1-chloroethyl hexane.
So I think because like chloro over here is the substituents of the substituents over here.
Which is the actual substituents of the parent chain.
Yeah.
Correct. So what we are doing, we are in the substituents. Leave the parent chain now. In the substituent, it's not 2. It was right, Arav. Just a second. Hold on, everyone. Hold on. This is the parent chain. Let it be. Right. Now this we have to define. So in the parent chain, if branch is there, right? So we have to start numbering from the carbon atom of the substituents which is attached to the parent chain. So we are bound to start the numbering from this carbon, numbering on the substituents. It is like this, 1' and 2'. Right? So 1', this carbon is the first carbon we have, no matter where the branch of the branch is present. Like for example, if I take this one also, 1, 2, 3, 4, 5 like that, and here suppose chlorine is attached, then also it will be 1' and 2'. And the name of this compound is 1, 2, 3, 3-2' chloroethyl hexane. Did you get this? The name of this compound is 3-2' chloroethyl hexane. Is it clear to all of you? Right? So this you try to understand the complex substituents. Okay, this name you let it be. I am not taking the functional group now into the consideration, but this is how we do the numbering of the complexion. However, this is not correct. Just you take care of this numbering part, because this is a functional group. We haven't discussed about the functional group now, right? So we'll discuss about functional group later, but just try to understand the numbering. How do we do in complex substituents, right? If you do the actual naming of this compound, we have to take this as the parent chain because it contains functional group. But however, this you let it be. This even you do not consider, because this should be the actual parent chain. What a point I'm trying to make, that if the complex substituents is there, then we always start the numbering from the carbon atom which is attached to the parent chain. So we are bound to start from this point. Now you can take this as the second carbon or this as the second carbon. Both are equivalent position. I am taking this as the second carbon. Now this position, suppose I am starting it as 1, 2 and 3, which is obviously right, right? So the name of this compound, the complex, if you see, since this is the parent chain, so this methyl is the substituent to this parent chain. So then the name of this part only is 1' methyl ethyl. 1' methyl, this group is ethyl only. Now this entire group is attached at this ring, so it will be close bracket 1' cyclopropane. How many of you understood this? To differentiate the numbering, Shashwat, like the parent chain will take it as 1, 2, 3. So in the complex, we'll take 1', 2'. However, in some books, you'll see they have taken 1, 2 also in the complex substituents also. It's methyl ethyl. Ethyl is the parent chain in the substituents. You see, for the substituents, what is the parent chain? Parent chain is ethyl. So parent chain will write in the last. Methyl is the substituents. So first we'll write methyl ethyl, 1' methyl ethyl. Did you get it? All of you understood? Anurag, did you understand this? You know, what do you want to think? What is your doubt? Tell me, Anurag. Are you clear with your doubt? What is your doubt? Tell me. No, I am waiting. I am waiting for his doubt. I am waiting for Anurag to text. That's what, see, Anurag, thing is, try to understand. The point is, it is not a test, right? If you want to answer, correct, then you won't listen what I am talking. First, you listen to me, then you can answer, right? So what I am telling you, that in the substituents, the parent chain is this ethyl, right? If you have two different substituents, ethyl and methyl, then we'll talk about the alphabetical order, right? If I give you this question, just see this one. What is the name of this compound? You'll say methyl butane, right? 1, 2, 3, 2 methyl butane, correct? 2 methyl butane. Why we have taken this butane here? Because root word is butane, right? Root word is but here. Similarly, if you have this compound, then for this complex substituents, the root word is eth, right? Methyl is the substituents here. That's why we write 1' methyl ethyl. Why it is ethyl? Because this is also a substituent to this parent chain, right? So root word for the substituents is eth. That's why we write ethyl in the last, first methyl. Now it is clear? Think about it, and then we can discuss it next class also. Okay. Methyl, ethyl, we won't write in complex substituents. Think about it once. Okay. Anyways, so we'll take one more example to understand the complex substituents, correct? Now, all of you try this. Think about it and try this. Don't hurry in answering the question. Okay. Just give it a thought first. Could you tell me the name of this compound? Okay. Fine. Now you listen to me. Yes. Now you listen to me. Stop texting and now you listen to me. Otherwise, again, you'll get confused. It'll take some time. Okay. First of all, we have to find out the parent chain, right? So what we'll do, we always take the terminal carbon. So 1, 2, 3, this is one chain we can take, or we can also take 1, 2, 3 as the parent chain, right? So 3 carbon we have here, 3 carbon we have here, 3 carbon we have here. Even in the ring also we have 3 carbon, right? So obviously the parent chain is what? The parent chain is a ring, correct? Now, parent chain is the ring, correct? So now this becomes the complex substituents. So now the first carbon of the complex substituents will be this. Why this carbon? Because this carbon is attached to the parent chain of the molecule. So this becomes the first 1 prime. Now 1 prime is this, so you can take this as 2 prime or this as 2 prime and this as 2. See, this prime is just a number we are using to differentiate the numbering in complex substituents and parent chain. We are using this prime. Even in some book they have taken 1, 2 only for complex substituents also, right? Just to differentiate that the prime means the numbering in complex substituents, and simple number 1, 2, 3 means numbering in this thing, the parent chain. Okay, so this point is the 1 prime. Now we can take this as 2 prime or this as 2 prime or this as 2 prime, anyone, because all 3 positions are equivalent position. But suppose if I have taken this as 2 prime, right? So this becomes this thing, this becomes the parent chain of the complex substituents, which has 2 carbon atom. Yeah, right. Okay, so if I like draw it clearly, you see this, a bigger picture I'll draw. So we have this actually, right? So I have taken this as 1 prime and this as 2 prime. You can also take this as 2 prime or this as 2 prime. That won't affect the answer. Okay, now here the parent chain in the complex substituents is this. This is the parent chain of the complex substituents. However, overall the parent chain is this of the molecule. Now, if you try to write down the name of this, since we have only 2 carbon atom in the complex substituents, it will be ethyl first of all. And at first position, we have 2 methyl group present. So what we'll write? 1 prime, comma, 1 prime, dimethyl, ethyl, bracket close. Now, this is the name of complex substituents. Now, this complex substituents is attached at first position of this parent chain. So 1 prime dimethyl ethyl cyclopropane. Now you tell me. Because we have to start from this carbon. You cannot jump like this. Suppose we have this and you have started the numbering from this carbon atom. You cannot take 1 prime this, 2 prime this, 3 prime. This is not the way. Right? You have to go continuously. It should be a connection, right? So 1 or 2, 1 or 3, 1 or 3. The condition is in the complex substituents, we have to start the numbering from the carbon atom which is attached to the parent chain. That's why it is. Now it is clear? No, not in this one. Here we use this. What is the connecting carbon? This one you're talking about. Anurag, this connecting carbon. No. We cannot take this as 2 because this is the rule. We have to start numbering from the carbon atom which is connected to the parent chain. That's why it is 1 prime. We have a capital letter here, cyclopropyl. Why ethyl, Tanishka? Because we have 2 carbon atom in the parent, in the substituents. So 2 carbon atom, hence it is ethyl. If I show you one more example here, suppose I have this carbon, this chain, 4 1, and then this. Okay. So this becomes 1, 2, 3. This is the parent chain, 4 atom, and this is the complex substituents, 1, 2, and 3. So name of this one will be 1 prime, comma 1 prime, dimethyl, 1, 2, 3 carbon we have, so propyl, bracket close, 1 cyclobutane.
Sir, if we add one extra methyl group over here, like in the substituents where you've written dimethyl, so instead of 1 methyl, you put 1 ethyl. So wouldn't that become the parent chain then?
How? Like you're talking about this?
Yeah.
So we have 1, 2, 3, 1, 2, 3. That also you can take. We have 2 substituents.
No, sir,
that won't make any difference.
No, sir, but wouldn't this be 5 carbon chains, or wouldn't this become the parent chain then?
Well, like, show me what you're talking about. This 4 carbon, then?
Yeah, then 1, then up.
Up.
So the same drawing which you did, but just an extra
carbon.
Yeah, an extra carbon on the
Where?
on this one.
Where?
Yeah.
Where? This side?
Yeah.
Like this you're talking about, like
yeah,
this.
Yeah.
So that is fine now. You see? Then this is the parent chain. 1, 2, 3, 4, 5. Or we can do the numbering in other way. Right, we can do like this. This is okay. Since this has 5 carbon atoms, so we can do the numbering this way. 1, 2, 3, 4, 5. So the name of this compound is what? 2-methyl cyclobutyl, right? So we'll write 2-cyclobutyl.
It'll be 3, why 2?
1, 2, acha, we have 3, correct. We have third position. So we have 3-cyclobutyl, then 3-methyl pentane. That's fine. Got it? 3-cyclobutyl, 3-methyl pentane. Correct? So obviously when you have a ring or a straight chain, To compare the parent chain, we'll count the number of carbon atoms. And carbon atom, when we are counting, we always count from the terminal carbon. We cannot start.
Yeah, but so you told that you have to start numbering from the carbon atom which is attached to the ring, right? So how can it be 1, 2, 3, 4?
Wait. I told you that when the ring is the parent chain. Here the ring is not the parent chain. First of all, we'll select the parent chain. No.
I didn't get
So
it.
parent chain is this straight chain now. So it's fine. It is not a complex substituents at all. If the parent chain is ring, like in this case, then we do not have any choice. We cannot jump here and start 1 prime, 2 prime, 3 prime. We cannot do that. We have to start from this carbon then.
Oh, so if the ring is not the parent chain, then you have to start from one of the ends.
Yes, then we'll check. Suppose you got this compound. First of all, we'll identify the parent chain. Ring, this straight chain is the parent chain. Then we'll start numbering this parent chain from either side, this carbon or this carbon, depending upon the position of substituents.
Okay.
Correct.
Yeah,
So this is 1, 2, 3, 4, 5. So here it's fine. But if ring is the parent chain, then we always and in this case is not at all about complex substituents. It is simple substituents. Right. Even in this also, you see, if I do this one, suppose one change I'll do, right? Just let me just do this change. Probably you'll understand this. Suppose I give one more carbon atom here and I'll do this change. Then obviously the number of carbon atom in the parent chain is 6 here. Correct? But this is the complex substituents. Correct? This is fine. 2, 3 cyclobutyl, it's fine. But this becomes the complex substituents. Now in this, if you try to find out,
no, so but then so you can start numbering from down, right? So then it won't be complex substituents then. If you start numbering
1, 2, 3, 4, 5, 6.
So
1, 2, 3. So we'll have 3. Yeah, so that's a difference case. So I'll just draw one more carbon atom here. Then also I think 1, 2, 3, 4, 5, 6, 7. So it's fine. So that is the numbering will be different. So let it be as it is. Okay. But point I'm trying to make is what? That if this becomes the complex substituents, right? If this becomes 1, 2, 3, 4, 5, this becomes the complex substituent.
Then you have to start numbering from the center.
Then here we have, it is 1 prime and this is 2 prime. We cannot give this 1 prime and 2 prime. That is the point I'm trying to.
Got it.
Okay. So first of all, you have to identify the parent chain, right? And then you have to do the numbering into this. We'll do some more questions on this. I know you have some doubt. Okay. It is not that, confusing also. Maybe, you are doing this first time. That's why you are having this out. But anyways, so we'll wind up the session here, guys. Next class, we'll start with this complex substituents only. We'll see some more examples on this. Correct? Understood?
Sir, what about the test?
Yes, I am coming to that point. Test, you will have very simple questions. It will be around for 30 minutes test will be there. There are some compounds. You have to write down the name of that compound, IUPAC name, and you have to send the answers to me. You can click the picture and send it to me on WhatsApp, on my personal text, not on the group. Okay. And there are some multiple choice question also. Yeah, MCQ will be there. MCQ plus some structure will be given. You have to write down the IUPAC name of that. Okay. Few questions will be there, like 1 or 2 questions will be there. Mix up will be there. Right. But mostly it's time will be half an hour. Everything will be there. Right. So basic nomenclature questions, organic chemistry questions it is there. Like I said, 2025 MCQ question will be there, and there are few structures will be given. You have to write down the name of that. Okay. That is it. So simple test is there. Okay, on Sunday. No, I'll share the PDF. It's not on LearnList. So I'll share the PDF with you on the group. Okay, you can take the test, write down, suppose 20 questions are there. You can write down from 1 to 20. You can write down the answer 1A, 2B like that. And those structures that are given there, which you have to write down the name. Below that, you can write down the name. This is this, like 1A is this, 1B is this, 1C is this. And take a picture of that, you can send me. Okay. Time is not much. I think half an hour will be there. Okay. I don't remember the number of questions exactly, but it is not that much. Okay. Don't worry. Yes, correct. Not drawing. only naming and structures, maybe like whatever we have done, it will be there. Whatever we have done till today. I will send you the paper Sunday around 10 o'clock in the morning. Okay, you can take the test and you can send the answer back to me by 3-4 o'clock, like that, in the evening. Test is on Sunday, Arav. Anything else? Okay, fine. Thank you guys. Bye.